Introduction to sets. A set is a collection of well-defined objects. Objects in a set are called elements. Sets are usually denoted with an uppercase letter, for example, capital A, and listed within braces. So we have a brace on the left side and the right side. They're also known as curly brackets. And the numbers that are between our braces are the elements of our set A. So we have -3, -2, 0, 1, and 4. When stating which elements are within a set, the Greek letter epsilon is used. So this 0 and then epsilon A is actually read as 0 is an element of, that's what the epsilon stands for, is an element of set A, or 0 is contained in the set A. When stating which elements are not within a set, the Greek letter epsilon is used with a slash mark through it, meaning it's not an element of, or it's not contained in the set. So this 2, the slash through the epsilon and then A, is read as 2 is not an element of set A, or 2 is not contained in the set A. There are two methods commonly used to describe or represent a set. There's statement form and there's roster or tabular form. Statement form is a written statement that describes the set of numbers. For example, a set B is defined as the first 5 counting numbers greater than 0. And in roster or tabular form, it is a list of numbers contained in a set, and they are written between two braces and separated by commas. So our set B is given in statement form above, and in roster or tabular form, it's written as 1, 2, 3, 4, and 5 in between curly braces. An empty set is a set that contains no elements. For example, another set B could be an empty set represented by two curly braces with nothing in between. Or you could also write an empty set using the Greek letter phi, which looks like a little circle with a line through it. Two sets are equal if they have exactly the same members. For example, set C consists of the numbers in roster or tabular form of 0, 1, 2, 3, and 4. And D is written in words, is the set whose numbers are the first 5 whole numbers. Well, the first 5 whole numbers, they start at 0 and then continue, and it's only the first 5. So here are the first 5. Therefore, if we were to rewrite D in roster or tabular form, it would be identical to C. Therefore, sets C and D are equal to one another. Here's another example. Set A consists of -3, -2, 0, 1, and 4, and set B is an empty set. Sets A and B are not equal to one another because they do not contain exactly the same members. Let's try an example. We have a set F, which contains the elements 1, 2, 3, 4, 5, and 6, and set G is an empty set. Determine whether each statement below is true or false. First one, 5 is an element of F. Well, we can see here is 5, and it is an element of set F, so this is true. Our second one, 2, is not an element of F. Well, 2 clearly is an F, so this is a false statement. G is an empty set. That is a true statement because there are no elements within the braces for set G. The next one, 1, is an element of G. That is false. There is no element of 1 within the braces for set G. And the last question says F is not equal to G. Well, this is true because set F has 6 elements, set G is an empty set. They are not equal to one another, so this is a true statement. And here are the solutions to all the example problems that we just worked through, and the solutions shown on this slide match the solutions that we found when we worked through it together. Here's another example. We have a set H, which consists of the elements 2, 4, 6, 8, and 10, and set I is an empty set. Determine whether each statement below is true or false. First one, 8 is an element of H. Well, that is a true statement. Here's the element 8, and it's contained within set H. So this is true. 5 is not an element of H. Well, that's also true because there is no 5 in this set. Now let's look at the next one. 1 is an element of I. Well, I is an empty set that contains no elements, so this is a false statement. The next one, I is an empty set. This is a true statement. You could either write it with the Greek letter phi or as a set of braces that contain no elements in between them. And the last one, H is equal to I. Well, we can see that H is a set of even natural numbers from 2 to 10, and I is an empty set, so these are clearly not equal to one another. So because this says H is equal to I, it's a false statement. And here are the solutions to our example, and they do indeed match the solutions that we found when we worked through each example.